How long does it take for an investment to double in value if it is invested at 10% per annum compounded monthly? What does per annum mean?
Per year.
Per year. Annual, yeah, that's correct. So we're talking about our nice, straightforward. Why is there no n in there? The n is actually there, but what is it?
It's 1.
It's 1, so you just don't write it.
What
Number of times compounded per year. So if it's yearly, n is 1. What's our interest rate? 10%.
Oh, just 10%.
We don't know what t is. We don't know what p is, but what are you trying to end up with? 2p. What cancels from both sides? P. So you end up with 2 is equal to 1.1 to the t. What are you solving for? T. That's it. What form is that in? Can you say it without trailing off like this?
It's in exponential form.
Good job. Way to go through. I think there's a verbal technique. It's called like speaking through your line. I don't know. You can help me with that. Not trailing in everything you say, right? You rise to the occasion, right? Yeah? We'll work on it. It's fun. This is going to be a great class. Yeah, exactly. Here's part of the reason why we studied logs. So log base what? Of equals. So if you're plugging this into your calculator, t is equal to ln2 over ln 1.1. I used ln because I like 2 letters instead of 3. You can choose any base you want. You could do log 2 over log 1.1. So if you do that out, what do you end up with? Anybody do that for me? ln2 divided by... Yeah. For a question like this, this would be a time when it'd be nice to know. I would look specifically for ln2 divided by ln 1.1 or log, but to answer this question out loud, I could ask you, like, how many years to the day? To be annoying, I could ask, it would take you 7 point that many years, and then multiply, 0.2725 times 360 to get the days. Yes? Oh, and then, compounded monthly. Okay, so that was if it was compounded yearly. Excuse me. Okay. So now, if we actually answer the question they're asking, it would be 2p is equal to p times 1 plus 0.1 over 12 to the
12 times
t. Exactly. Very good. So 2 is equal to 1 plus 0.1 over 12 to the 12t. So that's going to be log base 1 plus 0.1 over 12 of what? 2 is equal to 12t. So t is equal to 1/12 times log base 1 plus 0.1 over 12 of 2. So if you're going to type this into your calculator, you would have ln2 over 12 ln of 1 plus 0.1 over 12. You just have to be careful multiplying that out. I mean, if I would do that, I would do ln2, press enter. I would then divide it by ln of 1 plus 0.1 divided by 12. And then what do you multiply by, or divide by? 12 at the end. So I end up with 6 years. Is that shorter or longer? It's shorter. Why is it shorter?
Because you compound it.
Yeah, we're actually compounding it. Remember, things grow faster if they are, the more you compound, the faster it grows. So it does make sense. It should take less time, because the first time we ran this, it was compounding it once a year. Now we're doing it every month. Okay? So we actually save about a third of a year, so almost, 4 months. Okay, next one. What do you want to talk about next? Hands.
We just didn't say compounded continuously.
Oh, now we do the second one. So if we want to do the continuously, well, that's so 2p is equal to pe to the rt. So you have 2 is equal to e to the rt. That's the time to double, right? So 2 is equal to e to the, what's the interest rate? 0.1 t, right? So ln, so that's ln of 2 is equal to 0.1 t. So t is equal to 10 ln 2. And what does that equal? I can do that out for you. So 10 ln 2. So is it even shorter? Yeah, it's not as big a jump down, because as you compound more and more and more, it will go faster, but less and less of a gap. Now we've answered it properly, yeah. So if you compound it every instant for an infinitesimally small amount of interest, that's how fast it would take. That's how long it would take. Yes?
Is the difference between continually and
Continually is functionally what? Yeah, you use continuous interest is PE to the RT, and continuously, functionally, as in what's going on, it's compounding every instant, every single instant. Yes.
Shouldn't that technically mean that it's more, like a lot? That's a lot.
No. We are solving for time on this one. We're trying to figure out how long it takes to double. So it's going to take less time.
Yeah, but
If it's
doesn't take much less time.
I understand because the gap, the jump from yearly to monthly is going to lead to a much faster acceleration than going from monthly to instantaneously. It's not a linear relationship. It does the most speeding up at the beginning of what we consider the units we use. It gets really close to it, right? Like, so you could go from every day to every millisecond. It would probably only take like it would only go this much faster.
We had that horizontal asymptote.
Yes, it slows down as it approaches the asymptote. Okay, hand is up there in the middle.
24.
Logic.
Yeah.
Sorry. Can't continuously only really be as fast as your computer.
This formula PE to the RT is logically what it's doing is it's compounding interest every single instant, infinitesimally small amount of interest every time. And the way that's calculated is it's not directly calculating; it's calculating the limit. What you're running into is I can't do the proof of this. The limit as n goes to infinity of 1 plus 1 over n to the n is equal to e. That's the key to this that we can't prove in this class. That is one of the many definitions of E, but the point is that you're not. You're right. I mean, if you tried to break it down if you tried to plug in a hugely big number, right? Wouldn't you need a supercomputer if you're going to plug in a 100-digit number for n? Absolutely. But the point is that's not how it's calculated. There is a proof for this that shows that this is equal to E without calculating it with some 100-digit number. You've done this before. Remember the root 2? We proved that root 2 is irrational. Proving something irrational is proving you can't write it as a fraction, which means it goes on infinitely without pattern. Do we ever have to deal with a billion-digit number to prove it's irrational? No, you absolutely don't. There are ways to prove things without doing it directly. You can prove something doesn't exist without checking every single thing. There are ways to do it, and we did it with this one. Okay, moving on to questions on first page. 3 through 36, multiples of 3, other ones. 24, did you say 24? No? Which one, Andy? Which one? Number 9? Number 9. Okay, sure.
Is that a Gauss formula?
Let's do this here. Number 9. So you're just supposed to find how much money you have if it's $100 invested, 10%. So what's your question about this one? What's the formula you're supposed to use? Nope, it's compounded continuously. That's correct. Yep. So fill in the blanks. So where does 100 go? For which one? Yep. E to the, what's the interest rate? And how many years? 2.25. Yeah, I mean, you're going to have to plug this into your calculator so you can write it as a decimal. And then you just press enter on your calculator. That's it. That's all you do. How much money do you have?
Can we do,
Which one?
18?
18?
I think, actually.
Nope.
Same with this one.
Isn't it the exact same thing? 18.
No,
It's the same thing.
Backwards.
How do you, oh, 18 is different. I'm sorry, 18 is different, but it's the same process. You're just solving for a different variable. Sorry, we'll do that one. It is a little different. So if you're working on this one, to get $800, you're trying to get $800. So it's $800 equals a certain amount. E to what's the interest rate? 0.8 times what? 2.5. And now you just solve for P. So P is equal to 800 divided by E to the 0.08 times 2.5. Press enter on your calculator. Done. Done. Okay. 24. Hold on. There was a bid for 24. Yeah. 24. So now you're finding the interest rate. Now you're finding what interest rate do you need. So they're giving you all the parameters except the interest rate. So you want it to double in 10 years, I think is what it says. Is that what it says? What annual rate of interest is required to double an investment in 10 years? Verify your answer using a graphing calculator. That just means use a graphing calculator. So we're trying to double it in 10 years. So you're trying to find the interest rate. So you are starting with, you're going to 2p. You're starting with a certain value. 1 plus r. And are we compounding it at all? No. to the 10th, right? What cancels? So you have 2 is equal to 1 plus r to the... How do you get rid of a 10th power? Bingo. 10th root of 2 is equal to 1 plus r. So what does r equal? 10th root of 2. Yeah, and if you do that on your calculator, 2 to the 1/10 is 0.1. You could write it out as, if you wanted to, 1 divided by 10. Press enter and subtract 1. So what is the percentage?
70%.
Yeah, round to 3. Just get into the habit of doing that. So if you round to 3 decimal places, so you're looking at 7.177%. So if you want to double it, 7.7, sorry, that's not percent. What is that? Yeah, it is percent. I'm sorry. So if you want to double your money in 10 years, compounded yearly. Was this yearly? Yeah, if they, it's yearly. It's going to be yearly, yep.
If you're trying to find the nth root of something on the calculator, how do you just...
To the 0.1.
I know, but like just in general, like...
You raise it to the 1/10. You want to actually type it in directly? I think it's under math. Right there.
Yeah,
See, look.
I can find it, but how do you put in X?
You don't put an X. What you do is, I think you do, let's try this. I think you do 10, math, oh, math 5. Yeah, 10th root of 2.
Oh, okay.
You just type 10 first. Yeah, that is a little weird. I don't really use that. I always have done the fraction, so I never do that. Yeah.
Another
Oh, yeah, another one. Okay, let's see if you can polish these up. Any others through 36?
Well, actually, I'm
Yes.
thinking about the equations. You had originally you taught us A equals P.
A equals, yep, P times 1 plus R over N to the NT. But if it's yearly, what is N?
1.
So it goes away.
Yes, but then you also switched to P E 1 plus R.
Yes, and that this is for compounding anything besides continuous. Continuous, this is its own thing. This is for continuous interest right there.
That just means yearly. Oh.
This means continuous, 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 continuous interest. This means everything besides continuous. What this means is if n goes to infinity, it turns into that equation. If n goes to infinity, that's the equation it becomes. I can't prove that because you have not taken calculus.
No,
Yeah.
I don't
Yeah.
but continuously just means one every year.
No, continuously could be continuously for any amount of time you want. It just means it's being compounded every single instant. That's what it means. There's no time restriction. The time is t. You're running this for as long as you want. So, for example, let's say you had $187 and you put it into an account earning 18% for 72 years. That would be, your amount would be 187 times e to the 0.18 times 72. It would be a bunch of money.
Okay, so and then say you do it for like quarterly, then you would have to use the other equation. Not if it was continuously.
Continuously is a type of compounding. You can't have quarterly continuous. Quarterly means it's being compounded every quarter. Continuously means it's being compounded every instant.
Oh, okay.
Continuously is a type of compounding.
Do the banks use
Continuous, yes. 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 Not as directly as, not as simply as we put it, but yes.
Why did they change? Why with the expense? Why?
Didn't we talk about this yesterday? I thought we did. How often does money go in and out of a bank? Constantly. If you don't take, what they do is they do a mix sometimes. It depends on the account. Sometimes they, remember the average daily balance, we talked about that? They look at your average daily balance and will do a percentage of that. But that's essentially doing continuous interest, essentially. Because what they're doing is they have to use, to calculate your average daily balance, it's complicated. Because, for example, let's just talk about this, for example. 6 here, they do something tricky. So Sears charges 1.25% per month on unpaid balance for customers. So if you had $200 balance for 6 months, what's your bill going to be at the end of 6 months? So you have to set up, you're trying to find the amount. What's your starting amount? 200. 1 plus, what's the interest rate? What's the interest rate?
1.0125.
Oh.
Thank you.
Over.
What?
6.
It's monthly, so divided by?
12.
And we raise it to the?
12 times 9.
12 times what's the time?
9.
Nope.
6.
Nope.
6 months.
Nope.
1/2.
1/2. It's always in years.
Oh.
So, someone do that on their calculator. And I think it comes out to 201.25. I think. Did someone do that? Everybody do this on your calculator. It's amazing. You ask one person to do it, they do it. You ask everybody to do it, no one does it. Half a year, 6 months.
Oh, okay.
Is that what it comes out to? I'm trying to remember.
Yeah.
It does? What's the problem with that, though?
That's really small.
What's 1% of 200?
Two.
$2. 1% of $200 is $2. So after 1 month, you should owe at least $202, right? What's the problem?
Not what you are.
Yeah. Can someone tell me there are 2 words in this that kind of mess you all up? Do you know what they are, Brooke? Can you sign them to me? Which one? Which word? The second word? Second line? No, it's in the first line.
Unpaid balance?
Nope.
Charging.
No.
Per month.
Per month. What do they tell you? They tell you that this is the monthly interest rate. So what do we actually not do in this question?
Oh.
Transfer that.
You don't divide by 12. They've given you the monthly interest rate. They've given you the monthly interest rate.
Wait, so you just put that in.
So when...
No, honestly.
Listen, everybody.
Don't divide by 12.
Don't divide by 12. That's the whole point on this one. You don't divide by 12. They give you 1.25. This is a deceptive practice, Nate. This is a deceptive practice because what did I tell you? Interest rates are almost always written in. Yearly, right? You see things like your yearly interest on a bank account, 7%, which would be high. 4%, average, 3%, a little lower, right? Credit card, higher than this, right? What does this 1.25 per month correlate to yearly? 12 times 1.25. If you need to use your calculator, you should stop.
Like 27.
Wait, so far this class I've asked what is 1% of 200 and I've gotten 50 cents.
Okay.
And what is 1.25 times 12 and I got 17.
15?
I should do that. We should call the class that way. I should ask random trivia questions. Yes, it is 15. It is 15. It's 15. It's 15. So this is a pretty. Is,
I'm sorry.
the point of 15 is when they say 1.25% monthly. What are they actually saying?
15%.
15% yearly, and that's what you think of things as. This is what we'll talk about in a second. Effective interest rate. You need to have a common way to look at interest rates.
Isn't it
You need
different
to.
if it's compounded?
Yes, but this equates to if they had said Sears charges 15% per year compounded monthly. That's the exact same thing as they're saying right now. But when you see 1.25%, what do you think in your head? You can laugh when you learn how to do basic multiplication. Yes? You look at it and you're like, wow, that's a really low percentage rate. But is 1.25% really low? No, it's not. Because I'm just really that funny is why.
Because I said 1% of $200 is
That's why. It's pretty good. We're going to come back at that. We'll come back to that.
It could be in the remix.
So, yeah, it'll be in the remix. So if you do this, could someone do that on their calculator and tell me what it actually is?
Right, Neo.
We're at Neo.
Rate of interest.
What does effective rate of interest mean? Exactly.
What it would be if it was just
Here you go.
yearly?
What? If it was just what?
Yearly?
What would the interest be if it was just yearly? So, for example, if I say you have a certain percentage rate and you're compounding it monthly, you'll end up with more than just that percentage once. For example, if you had $100 and you do 10% of that once, you end up with $110. But if you compounded that continuously, would you end up with more or less than $110? More. So you try to find out what would be the percentage rate if you just took the percentage once. So for this one, it says 5 1/4 compounded quarterly. That's 1 plus 0.0525 divided by what? Raised 1 year to the what power? 1 year times 4. So if you had $100, what does that do to $100? I think it turns it into $105.35. Someone can verify that while I'm talking. What would be the effective rate of interest? It turned $100 into $105.35.
I got 5.
Bingo, Gare. 5.35%. Exactly. Look, it turned $100 into $105.35. So what's the effective rate of interest? 5.35. 5 1/4 compounded quarterly is the same as 5.35 compounded once. Why is having the effective rate of interest something that is very valuable and something that you see all the time?
Because sometimes you can choose your...
Compare and you can choose.
Yeah.
For example, if I said, okay, you have a choice between 12% compounded yearly or 11.5% compounded quarterly, or 11.25% compounded continuously. In your head, do you have any idea which one is the best? No.
They asked us about that in 27.
Exactly. So what do financial institutions have to report? They report something that is the equivalent of
Like the monthly?
effective rate of interest.
Okay.
They take all of their packages and say, this is what the effective rate of interest is. When they do it, there are other things that go into it. When you take out home loans, when you take out home loans mainly are the big common ones,
Yep.
there are other fees like origination fees. There's tons and tons of fees on different loan types. What they do is, by law, you have to be given something that is the equivalent of the effective rate of interest so that you can easily compare. Why is that something that's very important?
Government doesn't steal your money.
It's not the government here, kids.
So people are
Pretend
not
that you're not a Vermont redneck. And we're going to let you keep your guns, yes?
We're not getting tricked into
Yes!
like getting a loan that we can never ever pay off.
Yes, exactly.
Why are government trusts?
One of the many reasons that the Americans are facing the economic crisis is what? Many Americans ended up with loans they could not pay. Why? Why?
The banks fail.
Not because the banks failed. The banks failed because they did this. Because they did what?
They charge for the effective rate.
Nope. Well, not just that. People ended up with loans they could not
They let people borrow
Yes,
money when they
yes.
shouldn't
Okay.
have.
So who's the adult in this situation? The uneducated American consumer or the banks that are supposed to actually know what they're doing? The banks, right? So yes, I do put some responsibility on people that can't do basic math, but I put more responsibility on the adults in the room. If I put some fireworks outside on the lawn and then some kids picked them up and like blew up, like did something terrible with them, who's responsible for that?
You.
I am, right? Yes, kids would probably get in a pretty good amount of trouble, but I'm the one that's responsible, right? So if I give out loans that I know will default, it's my fault. Unfortunately, the way our justice system works, you know how many bankers have gone to actual jail because of the billions of dollars that evaporated? Actual jail time, how many? 0 as far as I know. 0. 0. Should blow your mind. Should blow your mind.
Isn't it? It's called white collar crimes.
Not at all.
Well,
Doesn't matter.
the first one is
Are the terms of the loan going to change every year, Nate?
No.
So if it's good, if it's the best option for 1 year, it's going to be the best for 5 years, right?
So you can just say 100 on 12% for 1 year.
No, let me just ask, what is the effective rate of interest on A?
Well,
12%. On A, it's 12%.
Yeah.
Because what is effective interest?
Per annum.
What is it per annum,
year.
right? So for A, it doesn't get very complicated. It is 12%. Now, you could, well, not necessarily. You don't know that. Let's try this. B, it's a lower percentage, but it's compounded more. C, it's an even lower percentage, but it's compounded even more. So the lower percentage is good, but compounding means it's going to go back up. So you have to figure it out. So you actually have to do it out. Again, does it matter how much you put into the account? No. What you're actually looking at is just this. Your principal times 1 plus r over n to the nt turns into how much you have at the end of the course of the loan, right? Or the course of the investment. If we take away p, you
Right.
end up with 1 point something to, whatever factor you are multiplying by your original principal, you subtract 1 from it. Because, for example, on our first one, we went from $100 to $105, right? What do you multiply by 100 to get 105?
0.05.
No, you multiply by 1.05. 5% growth is multiplying by 1.05. What is the growth rate said to be? 5%. Multiplying by 1.05 is 5% growth. So if I ask you what the effective interest rate is, if you were multiplying by 1.12, what's the effective interest rate? 0.12, 12%. So what you're doing here is you're finding the factor here, the multiplication factor, but you're subtracting 1 because that's the original value you started with. So you actually just do this for B and C. So for B, it's 1 plus 0.115 over 12 raised to what power? Minus 1, because you're doing 1 year. I think this comes out to be 12 point... Can someone do that for me? 18? 19? Something like that? I don't remember. The first one is 12%. 12 point what? Okay, so you ended up with an answer of, can someone just tell me what the, point what? Point 1, 2 what? 1, 2, 1 what? Like that? So what's the effect, so what's the percentage? 12.125%? Do people agree with that? So what happened to the effective interest rate? It just went up. So even though we lowered the percentage rate, the compounding vaulted it back above the 12%. So ready? It is, but it's still different. So now we do 0.1125 over. Oh, it's continuously. Oh no. So what do we use? T minus 1. E to the RT minus 1, because does the P matter? No. The same place this one came from. You're subtracting the 1 out because you're subtracting the 1 out because look, we just went through this. What do you multiply by 100 to get 105? 1.05. We're interested in the 0.05 part. So you do this out, so what do you actually get for this? E to the 0.1125 minus 1. What do you get? 0.11 something? Tick-tock. Tick-tock.
0.119072225.
Yeah. So what do you end up with? That means it's 11.907%. So which one is the best deal for you? C, because you want to minimize what your payments are. Minimize. Now here's the deal. We as humans have that weird thing with percentages. We're not very good with them. Do you remember? Hold on. When you take out the loan, let me just do this first, then we'll get to questions. It starts here. Whatever that $200,000. The second I borrow that money from you, it starts earning what? Interest. So I suddenly start owing more than $200,000, right? At the end of the first month, what do I pay? I pay my mortgage payment, and all of a sudden it spikes down. But then it's still going to go down, up, down, up, down. And then after a certain amount of time, maybe 30 years, it's going to hit 0. But what has it done all the way until that point? The same pattern, right? What does this distance represent right here?
What the bank makes.
Nope. The mortgage payment. Every time you pay, it goes down, but then it grows down, grows a little bit, down, grows a little bit, right? Here's the deal. What's the tricky calculation? You want to know how much should you pay every single month so that at the end of 30 years you will have paid off everything. I cannot prove the formula to you, but this is what it is. Yes. Don't worry, I'm going to give it to you in written form as well.
As you get closer to finishing paying your mortgage, wouldn't they start making less interest on it?
Oh, yes. The amount of interest is going to go down. Yes, you're going to be hitting more of your principal, not the interest, but the amount you're paying is going to stay the same. Yes, absolutely. And then at there's a million different nuances to this.
Every month you pay less?
No, every month you're paying the same amount of money, but more and more of it will go towards the principal and not the interest.
Not paying off the... Okay.
Exactly.
Yep.
Because at the beginning, the interest numerically is much greater.
Right.
So let's just finish this. What this means is follows. This means that what this is as follows. The amount, A, is going to be your monthly payment. And we're going to talk about monthly because that's the most common one by far. P is the borrowed amount. I is the periodic interest rate. And I'll explain what that is in a second. N is the number of payments. Yes, I know this is poor labeling on my part, but let's just deal with it. Number of payments. So in terms of the variables that we know, the periodic interest rate you can think of as R over the N that we've done. The N that we've thought about is the frequency, the number of times per year of compounding. So, for example, remember the monthly interest rate? That was 1.25%. That would be called a periodic interest rate because that is the fraction of the year. So what does that mean? What's your first big purchase, maybe during college or after college? Car loans. There we go. Someone said it. I thought I heard it.
Yeah.
How much is the car going to cost you? $10,000. What's the interest rate going to be on the loan?
5%?
Let's say 5%. And what's a common length of a loan for a car?
4 years?
No way. 5 years at the most. 3 to 5 years. 3 to 5 years for a car loan. 3 to 5 years at the most. 3 to 5 years. That's gonna be too long. Let's say 3 years. Let's figure out what our monthly payment is going to be using this formula. The amount you're going to pay is going to be equal to $10,000, or 10,000 times I. In this case, it's the periodic interest rate. Periodic interest rate. 3%, this 5%, this is yearly. So what do I write as my periodic interest rate?
5% over 12.
Over 12, yes. But in this case, it's 0.05 divided by 12 times 1 plus 0.05 over 12 raised to what power?
3?
Close.
12 times 3.
Number of payments. This is number of payments now. Number of payments. How many payments do you make?
Well, if you just do it on your monthly though, so it's
36. Yes.
Oh, 3 years. Sorry, I thought it was 5.
3 years. I'm sorry. Yeah. Then on the bottom, it's the same thing. That little piece to the 36 minus 1. I cannot prove this formula to you with the math that you have. You just have to go with it for now. But this tells you a very interesting thing. Let's calculate it. What I want to...
All at once.
Please don't do this all at once on your calculator. I can guarantee you're going to misplace one parenthesis or 2 or 3, and what's going to happen? Your monthly payment will be $6 million. What I recommend you do, or 6 cents. You're like, wow, I really want to believe that. You see those two pieces? They're the same thing, right? Do that first on your calculator. 1 plus 0.05 divided by 12. Hit enter and raise it to the 36 power. I'm going to store that as A. Now, if I go and write this equation, it's 10,000 times what? 10,000 times 0.05 over 12 times A over what?
A minus 1.
A minus 1. Is that a lot easier to type?
Yeah.
Yes, it is. What is... Now, I'll type that out now. What was that? 10,000 times 0.05 divided... Oops. Times 0.05
It's 05.
divided by 12. I know. I got that. If I miss that decimal point, what happens?
It's close.
It explodes. Exactly. Then I have to multiply by A, right? And then I have to divide by what? Is that a lot easier to type out? Do it in pieces. Yeah. So what does that make logical sense? What is our answer telling us?
That'd be $300 a month.
You're going to pay about $300 a month. Does it make logical sense based on what you're paying? Yeah. Now here's something interesting to think about. So you're paying that much money per month? It does. They do round. They round to cents. And if you watch Office Space, you can get some funny jokes about what happens when you round.
They always round up. So.
Well, they round up, round down. I mean, it's better that you overpay a little bit than you owe more, than owing more at the end. No, hold on. No, that means if you pay that amount every month for 3 years, you will pay off your $10,000 5% loan, right? But here's the thing. How many payments are you making?
36.
You end up paying $10,789. Now, here's that seems like a lot, right? That's the overall interest you pay over the course of the loan. You end up paying how much interest?
784.
And 52 cents in interest, right? So you're like, oh my god, that's how they make money. You're like, oh my gosh, that's a lot, right? Well, watch this. Let's buy a house. How much is a house going to cost?
300,000.
It's not about the amount, it's about the relative amount, okay? This is what's important. Let's say just $200,000. Let's go even lower. $150,000. $150,000, right?
Small house.
Not in Vermont. Do you have any idea what you can get for $150,000 in Vermont? You can get a ton of space in Vermont for $150,000. So it's $150,000. What's our interest rate going to be? 5%. You know, I think it's at 5.5. Let's take 5. So what is it going to be? 0.05 over 12 times 1 plus 0.05 over 12 to the... Now, what's the common length of the loan?
5 years.
No, home loan.
30.
You have two options, generally, 15 or 30. Side note on this, when you get your home loan, you can pick any length you want.
Means you have to pay more.
More or less. The shorter the loan, the more you have to pay, but the less interest you pay, right? 30 years. Most common length by far. So how many payments are you making? 30 times what?
12.
Over 1 plus 0.05 over 12 to the 30 times 12 minus what? So we're going to do the same exact thing. 1 plus 0.05 divided by 12. What are we raising it to? 30 times what? 12. And we're going to store that as what? A. We okay with that? So now we're going to do 150,000 times 0.05 divided by 12 times A, right? And what do we divide that by? A minus 1. So what do we end up for a monthly payment? Yeah, look at that. We end up with a payment of... So here we go. There's our mortgage payment per month. Kids, pay attention. Stop passing notes. That's your mortgage payment, right? How many mortgage payments did we make?
30, 12,
Watch this. Do you understand what that says, everybody?
Yeah, that's how much you pay.
That's how much the bank makes off of you.
No, not that isn't the amount. It's almost.
Oh, well, it's
It's
minus,
the total.
yeah. Oh my goodness, how you chase the bank.
Almost 100%. So, just to be clear, everybody, just to be clear, in the current market, it depends on how long the loan is, but on currently, everybody, when you get a 30-year loan with about a 5% interest rate, depends on the length, this is completely normal. This is completely normal. By the time you pay off your house, you will have paid double the amount that the purchase price. That is double. That is completely normal. And guess what? Let's change the percentages just a little bit and see what happens. Ready? So let's keep it at, what do you want? Remember what I said the interest rates were before, like 11%?
Yeah.
Let's run this again. I'm going to pause this. You don't need this on recording again. But well, here's the thing. If you get a 30-year loan, if you get any loan, can you pay more than your minimum per month?
Yeah.
Absolutely. You can pay off things early. Absolutely. You absolutely can pay things off early. So you can send in like an extra $100, right? What will that do to how long it'll take? It'll take a shorter amount of time, right? You'll pay less interest, right? But here's the thing. I have a question for you. Okay, so you have Bob who gets buys house A, a 30-year loan package, okay? Pays it off, but instead of paying the 30-year mortgage payment, every single month pays exactly what he would have paid if he had gotten a 15-year mortgage. So he pays a lot more every time. Here's what happens, though. What interest rate is running over the course of the loan if you get a 30-year loan?
The 30-year loan.
The 30-year loan rate, which is like maybe 5.5%. If you get the 15-year loan rate, it's less. So even if you get a 30-year loan and pay it off with what you'd be paying if it was the 15-year loan, you'll pay slightly more interest because the rate that's running is higher. But here's the thing you're paying for. What are you paying for if you do that? You're paying for the right to not have to pay the amount for the 15-year mortgage. Do you understand what I'm saying?
Yeah.
So let's say the 15-year mortgage was $1,300, right? And you were pretty sure that you could do that, but you weren't entirely sure. You could get the 30-year loan and pay that amount as many times as you can. But every once in a while, let's say you couldn't make the $1,300, but you wanted to pay the $900, you could. But what do you end up paying for that right? You end up paying about, on a house like this, you probably end up paying about $15,000 to $20,000 more in interest over the course of the loan. But when you think about it, if it's 360 payments, and you're paying $15,000 more over the course of the loan, that means you're paying about $60 a month for the right to pay less per month. Does that make sense, everybody? Mm-hmm. Which, in the long term, can make a lot of sense because you don't want to put yourself into a position of this is how much you have to pay, and if you don't pay it, what happens? You're done, right? You're done. But I just wanted to show you that because is it completely common to pay double the value of the house over the course of the loan?
Yeah.
Absolutely. The vast majority of... Oh, I just outlined it for you. That was with a 5% interest rate. What have I already told you about interest rates being at 5%? That's really, really...
Low.
That's really low. What happens if the interest rate goes up to like 10 or 11%?
Pay like 2 or 3 times.
You're going to pay 2 or 3 times that in interest. Mm-hmm. The vast majority of people in this country buy a house. The vast majority of people do not pay 20% down. So they end up paying at least 6%. At least 6%. The vast majority of the people in this country will buy a house and end up paying at least the value of the house in interest if they end up paying off the house at all. The average American spends 5 to 6 years. The average length of any mortgage in the United States is about 5 to 6 years. Do you understand what that means?
No.
The ownership of a house changes on average every 5 to 6 years.
Oh, okay.
That's what it means.
So people won't hold on to a house for 30 years and pay the whole mortgage.
Exactly. So here's the thing. So that's another reason. That's another reason. If you're not going to be in a house for very long,
That's how you're gonna sell it.
And
You
you
tell the
want,
guy,
you don't want it to be like a.
You want to do that
high
bad
rate, so like-
interest.
No. No. You're thinking about it almost the right way. Think about it this way. If you're not going to be in a house for too long, this is way too long.